In 2005, I was diagnosed with severe obstructive sleep apnea. This was one of several respiratory issues that I had as a result of exposure to burn pits in Al Assad. I started CPAP therapy early on. At first, I absolutely hated it, but after a couple of weeks, I tried sleeping without the machine once, and I woke up with such a severe headache and feeling so terrible that I never slept without it again. Over the years, this has certainly not been fun, but it's the only thing that's worked for me. And my apnea is bad enough that I can't sleep without it. I've also never been content just to forego things like backpacking just because it's not easy to bring a CPAP machine. So what I'm going to detail here is the system I'm currently using on the Pacific Crest Trail, and I'm going to go over a little bit of the things I've experimented with in the past and the pluses and minuses of each system. So I recently got my new machine, which is a Transcend Micro. This is the smallest, lightest machine that is currently made. It only came out last year. It weighs about half a pound. It's about the size of a baseball. This is what's referred to in the electrical industry as a barrel plug. It is sized by outer diameter and inner diameter, how big around the outside is and how big that hole is. So these are 5.5 millimeter by 2.1 millimeter, and that is what nearly all of your solar chargers and the batteries that are made to go with them will accept. You can generally also use a 5.5 by 2.5 millimeter, as the inner hole is a little bit larger. Generally speaking, it's going to make contact just fine, and it'll work electrically speaking. Now, because this is a medical device and it's proprietary, they use a really odd size. This one is a 6 millimeter outer diameter and a 4.4 millimeter inner diameter. And if you can see, there's a little pin inside it. I was able to find these adapters on eBay. So on this side you have your 6 by 4.4 millimeter 90-degree male end. On this side you have your 5.5 by 2.1 millimeter female end. This plugs into here. This plugs into your CPAP machine. Need that 90 degrees so it'll lay flat. And this end plugs into your battery. My battery I got off of Amazon. This is about $200. They weigh about 3.5 pounds. 72,000 milliamp hours, 266 watt hours. For those of you who don't know a lot about electricity and battery ratings, this is 72,000 milliamp hours, which means it's 72 amp hours. What that means is that it will provide 1 amp of current for 72 hours. Now, to convert that to watt hours, which is going from current to power, you multiply by 3.7, which is the nominal voltage of a lithium polymer cell. It varies somewhat. At full charge, it could be as much as 4.2 volts, and then as it discharges, it drops. So, for comparison's sake, a really large phone battery would be 4,000 milliamp hours at the same 3.7 nominal voltage. So, you could charge a cell phone, almost a very large cell phone battery, almost 20 times with this, but it'll run my CPAP machine for 2 to 3 nights. One of the advantages of this whole arrangement here is that all the combined power of my cell phone, my Bluetooth headphones, my smartwatch, my Garmin Explorer tracking device, it's all a rounding error compared to the amount of power I'm using with my CPAP machine. So I don't pay that much attention to how much, being in airplane mode, being in power saving or whatever, unless I don't want to deal with the hassle of charging my phone on the trail. But ultimately, I have a huge amount of power at my disposal. Now, all these types of batteries and power stations and things you'll find on Amazon and eBay. They're mostly made in China. A lot of times they lie to you. One of the ways that they'll do that is, for example, as I told you, the per cell voltage is 3.7 volts. And so the correct way to derive the total amount of capacity in watt hours is to multiply by that. Now, if you have a 3S battery is running 3 sets of cells in series, which gives you about 12 volts. You get 3.7 times 3 is 11.1. They round up to 12. So if they're being dishonest, what they may do is take the amount of milliamp hours and multiply by 12 instead of 3.7. You see that a lot in the cheap batteries you see online, the different types of packs. But it's not the case. So what these batteries are doing is they're running a series parallel circuit. So say, for example, you've got 12 total cells. Each cell runs at 3.7 volts nominal, and let's say they've each got 1 amp hour of capacity. If you ran them all in parallel, you would have a 12 amp hour 3.7 volt battery, which would be about 40 watt hours. If you switch that to a 3S series parallel, you've got 3 sets of 4 cells. 4 cells in parallel, and you're running those 3 sets in series. So that gives you a nominal 11.1. We're going to round it up to 12 volts. Now, your actual amp hour capacity for that system is 1/3. It is now 4, which gives you the same 40 watt hours of total capacity. Or you could run it all in one big series circuit, in which case you'd have a 1 amp hour battery that ran at 3.7 times 12, which would be about 40 volts by 1 amp, which gives you 40 watt hours. So what they'll do is they'll say, I've got my 12 amp hours of capacity because I have 12 amp hours worth of cells and it's 12 volts. So I'm going to claim 144 watt hours, which is obviously not true. Now, in some cases, especially if you're buying individual cells, they'll just flat out lie about it. So, for example, if you're buying individual lithium-ion cells, you're usually buying 18650s, which it denotes that it is 18 millimeters in diameter and 65 millimeters in length. They're a bit like an extra large AA battery. Some of them will come with a button top and some will come with a flat top. And they also have like 26 650s and 32 650s and whatever. But 18 650s are the most common. Anything from power tool batteries all the way up to a Tesla is usually using the same size of cells, just more of them in big series parallel circuits. So it might be thousands of these individual cells. So when you're buying the bare cells, a lot of they'll just flat out lie about their capacity. Last I checked, is a little bit out of date, but not long ago, the largest cells you could get that were legit were 3,000 to 3,500 milliamp hours per cell, which would be made by like Samsung and a few reputable outfits that made the real cells. Then you get these cheap, no-name Chinese ones that would claim something outrageous like 18,000 milliamp hours per cell, or they just claim that they were the same capacity as the high-end ones when they were maybe a third to a quarter. But you're buying, it's almost like buying black market stuff. Like these are the things you'd see on Alibaba and eBay and so on and so forth. So, I mean, anytime you're buying batteries like this, they make batteries specifically for CPAP machines, but they are outrageously expensive and they're just too small. In some cases, like the biggest ones they make, it might be $500 for the battery, and it might only run your machine for 2 nights, maybe less if you're running at a higher pressure. I don't think they make any medical grade ones this size. And generally speaking, they won't take a solar input. Sometimes they'll have their special proprietary battery and their special proprietary solar panel. Each one is like 5 times as expensive as the stuff you could get online that's not specifically made for CPAP machines. So the reality is, to get the range and the power levels you need, you have to go to these sort of shady manufacturers that are not always honest about their power supplies. But I mean, the simple reality is there are physical limitations to what you're going to have. You're never going to see a battery that weighs 1 pound and has 400 watt hours of capacity. It's just, it's fairly linear. Now, I've taken some of my previous ones apart, and ultimately, like the actual battery inside was half of the overall thing, and particularly when I was dealing with those power stations that have the inverters and stuff. Once you chuck the inverter, the plugins for your AC socket, there's some extra heat sinks maybe that you only need for the inverter. You maybe cut the weight in half. I haven't opened one of these up because, I mean, it's seamless. It's all sealed up. So really, in order to not cut anything, might be able to get some of these rubber things off of the heat gun, find where the screws are and open it up. But I think that that a large enough amount of the total weight of this thing is the battery, so it's not worth the effort. And since it's all reasonably sealed up and pretty weatherproof, I'm inclined not to mess with it and just use it as is. That is also something of a function of the fact that I only got this setup put together shortly before my hike began, so I didn't have a whole lot of time to mess with it. I am a mess with it kind of guy. I'm definitely a tinkerer, so given more time, I'm eventually taking one of these things apart, and then I'll know how much of the weight is the actual battery, and if it's worth taking one of them apart. If I can save a pound, might be worth it. If I could save 2 pounds, it'd really be worth it. But that's neither here nor there. So here's your main port right there. This plug goes into here. You use this for charging with the solar panel, and it's used to power the machine. Now this has a variable voltage output. This machine takes an 18 volt input, but there's a certain amount of wiggle room with that. The batteries that they sell to go with it, which are not nearly big enough for backpacking really, run at nominal 14.4 volts, and the AC adapter they use runs at 19 rather. This one has options of 12, 16.5, 20 volts, and 24. Let's see there. Oh, it doesn't want to focus. So to enable this, you hold down this button until the red light starts flashing, and then you wait until you hit the voltage you want. When it stops flashing, power comes onto the machine, and it starts running. I've used 16.5 volts and 20 volts successfully with this machine. This is my newer mask. I had a different one when I started, and when the VA started providing my medical supplies, they sent me this guy. It's big, it's a little bulky to fit in a pack, but so far it's been fine. The one thing about it is, because of the larger volume of air, my battery usage increased dramatically when I first got it. But I put this piece of tape to cover up part of these discharge ports, and that got my power usage back into acceptable levels. Now my machine ramps up to 20 centimeters of water, which is the highest setting, because my apnea is quite severe. If you had less severe apnea, you wouldn't need as high of a pressure. At that pressure, the way I tend to sleep, I can run through this battery in as little as 2 nights. A cord can last me as much as 3. The more tired you are, the more severe your apnea is, and the longer you tend to sleep. So Now I carry a solar panel with me on the trail. This is a 60 watt portable foldable solar panel that I got off of Amazon. I think it was around $150. It weighs about 2.5 pounds. It unfolds about this big. It has these flip out stands on the back that let you set it at an angle so that when you're stationary you can angle it towards the sun. It's very important with solar that you get the right angle. It makes a very big difference in the amount of power that you get. Since this is a 60 watt panel and this is a 266 watt hour battery, in theory, you could charge this battery in about 4.5 hours if you're getting full sun. In the real world, that doesn't work. First of all, you're never going to get your full 60 watts out of this. Second, you're going to have conversion inefficiencies between here and the battery. Now, lithium batteries, as well as all batteries, really, you're going to have a certain amount of loss in the charging process. They'll run up to about 75% at full speed, and after that, it slows down. So you get that first 75% in a matter of a few hours, but that last quarter can take almost as long as the entire rest of it. You'll notice the same thing with charging your phones. Now, one of the irritations that I had about this battery is, if you read the literature, it's capable of taking a charge input on this port at up to 80 watts, but it only comes with a 40 watt charger. And since it's a proprietary battery, it would take quite a bit of research and possibly guess and checking and potentially blowing your battery up to find a proper 80 watt charger that would work for it. Now it will take 60 watts on the USB-C power delivery port. So what I do, rather than use the 40 watt charger that came with it, is I carry this around. This is overkill for what I'm doing. I could probably have one about half the size and half the weight to do what I need to do, because it'll only take 60 watts. This will output 100 watts on the main port, potentially 85 on the second, 60 on the third, and then you have a USB-A. I could charge 3 of these batteries simultaneously at full speed with this brick. Or I could charge this one and my phone and whatever other accessories I need to charge. One thing I was thinking about is, if I do a trail like the Appalachian in the future where it's green tunnel and solar isn't going to work, I could bring 2 of these batteries and 1 of these and charge them simultaneously whenever I get a chance, which is why I brought this in the first place. So, the ports on this solar panel, it has the same, well, you're not going to be able to see this, but in here you have the same 5.5 by 2.1 millimeter port that's on here. So this cable end to end goes straight from here to here. It'll output 60 watts on that output. It also has a USB-C power delivery capable port, which is rated at 60 watts also. So in theory, you could charge the battery from either port at full speed, but for whatever reason, they don't like each other on the USB charger. The USB on this will charge my phone at a good solid 25 watts, which appears to be the limit of what the phone will accept from third party. My phone's a Samsung. It'll take a faster charge from special Samsung chargers, but it'll only accept about 25 watts from the sort of industry standard ones. But for whatever reason, this won't charge off the USB. They're made by different companies. Sometimes they just don't get along. This also has a USB-A, which will allow you to charge your other general electrical things. Now, as a strategy, if you're charging this battery, you want to just charge this battery, because once you start divvying up, theoretically the ports will all work at the same time, but once you start divvying it up across multiple outputs, it tends not to be happy. You lose a lot of efficiency that way, and particularly if you're only getting partial power, you might end up essentially not charging any of them. Because, for example, the one on the phone will keep clicking on and off when you have excess power and keep turning the screen on your phone on. That can actually discharge the power on your phone faster than it's getting power from the solar panel. So one thing that I tend to do, you can't be stationary charging all the time on the trail. So I've been experimenting a little bit with the ways I'll hang this off of my pack and charge while I'm on the move, which means I have cords hanging off of me. It means I have this big thing hanging off of me, which when it's all the way unfolded, it's quite large. And if you're on a ridge in a high wind, it acts like a big sail. So one thing I've tried is you can hang it straight and try to angle it towards the sun. That way, theoretically, if it's at just the right angle, you get the maximum amount of power. But if it's not at the right angle, you're getting nothing at all. That also is the worst case scenario for wind and catching on stuff, all the physical parts of it. So what I've tended to do more recently is sort of wrap it around so that it's kind of like this, facing up at about 45 degrees with the sides out. Try to somewhat contour it to my pack so it's not sticking out too much because there's bushes and trees, although I'm in the southern section, so most of the bushes are down below the level where the solar panel sits. It's taken its share of bumps and bruises. It's got scrapes and stuff, and one decent sized gouge here. It's still working, which is good. Best to keep it as clean as you can when you're out on the trail. You know, you're not going to be spit polishing this thing all the time. Best you can do is wipe the dust off, but that seems to do the trick. But it does seem to have lost some amount of its efficiency, but it's really hard to be sure because all I have is the 4 indicator lights on this thing to tell me if it's at a quarter, a half, 3/4, or 100% charge, and guesstimate how fast it's charging based on that. I got a meter to measure power over USB-C, which I really wanted to test out, but unfortunately, because the USB-C output on this doesn't work with this, I couldn't do it. That's how I found out that I was getting 25 watts when I charged my phone. And then a lot of this was done kind of last minute because I was only able to get this CPAP machine at the last minute. And so I had to switch from a 12 volt setup to one that would support more like 18, and didn't have a ton of time to experiment. I ordered some components that I was going to use to make a little meter to measure over this line, but then they sent me the wrong stuff and it was too late for me to reorder it before I had to leave for my trip. So some practical things about using this machine. This will alarm out if it gets too hot or too cold. I think it's around 40 degrees Fahrenheit. If it's below 40-ish, it'll alarm out and it won't work. So I have to keep it tucked into my sleeping bag somewhat. I sleep with a hammock, and so if I'm in the hammock, I can just sort of tuck it all in next to me. You want to keep the battery in there too because the performance of lithium polymer cells drops dramatically when temperature falls off. It also drops dramatically at high temperatures, but at the moment that's not really a concern. Generally at night, that's never going to be a concern. So now here's another problem with that. If you have this tucked into your sleeping bag, this is the air inlet. It sucks the air in through a little foam filter. As this is rolling around in your sleeping bag, it's going to grab onto the sleeping bag material, suck it up against the air inlet, and then essentially clog itself up, and the airflow is going to stop. So, to work around that, I took one of these. This is the little foam, the little mesh pouch from a Toke's titanium cook pot. So I'll wrap it around here. It fits just about perfectly. And snug it up. And now the air goes in through all the little mesh and it's not able to pull the sleeping bag material hard up against the filter. So when I'm not able to use my hammock, I cowboy camp, and I've got, at first I had a big 2-person quilt, which was rated for 10 degrees. So that gave me extra room to sort of set all this stuff beside me off the side of my sleeping pad out of the way, and then wrap the quilt around it so that it was sharing my body heat to keep it warm. Eventually, I ditched that for weight purposes. I went down to my single quilt, and so when I'm cowboy camping, as I'm not using my hammock, I'll take the under quilt and I'll wrap that around all my stuff off to the side, because I don't want it on the sleeping pad with me, because I'm worried I'm going to roll around and crush it or turn it off. And this is my most expensive piece of equipment, because this guy cost about $900 on sale. CPAP medical equipment in general is not cheap. I was hoping to get the VA to cover it, but they're so slow with everything, I ended up having to just buy it out of pocket kind of at the last minute, which is why I had limited time to experiment with all this stuff. Before this, I had a Philips Dream Station. That was my only machine for probably about 10 years. That one recently got recalled. So the Dream Station was a full-size at-home unit, but you could split the main unit off from the humidifier and leave the humidifier at home. So then the main unit was pretty bulky. It was about, yay big, but it wasn't really all that heavy. It was maybe 1.5 pounds to 2 pounds. If you're not bringing the power brick, you just get your own little wire. Like you can get these kind of wires off Amazon. You just need to know which size plug to go on either end. And to be honest, I think it was a little bit more energy efficient. So I got to carry more battery to support this, even offsets somewhat the weight savings of the machine. So there is really no perfect system. That one also worked on 12 volts. It's a lot easier to get a 12 volt power source than an 18 volt one. And this kind of battery, when I first started doing all this stuff, backpacking with my CPAP, this sort of thing didn't exist. These are really new. So the first system that I had these 12 volt lithium polymer batteries that had a little pigtail on them. And they were just like bear cells, the blue shrink wrap. These were made for CCTV cameras. And the output on them was a little low, like they really were only rated for about 1 amp. So what I got is 5 of them, and I soldered together my own little wiring harness so they'd run in parallel. So each one was only drawing 1/5 of the power required to run the machine. And that worked fine. I couldn't solar charge that, but I used that for as much as 5-6 nights at a time. And it worked out all right. And then the next system that I used was I got one of those, what they call them, a portable power station. They have an inverter, so they've got a 120 volt outlet. And they have all this stuff that, frankly, I didn't need. And it was about 3 or 4 pounds originally. I think it was rated at 150 some odd watt hours, so not as much capacity as this. And I took it apart. I threw away the inverter. Luckily, the one I got, the inverter was on a separate circuit board from the control circuitry for the DC, for the charging, the inputs and the outputs. So there were 3 or 4 different circuit boards. Threw away the ones I didn't need. I threw away the case. I wrapped it in some foam and slathered RTV on the circuit board so they were weatherproof. And that worked all right. And then I had a similar solar panel setup that was longer and skinnier. So it was like 6 panels, I think, instead of 3, but they were smaller panels. I like this setup better because it's easier to arrange it around my pack so that it gets the most amount of coverage. Ultimately, I've been on the trail off and on for about 1.5 months, and this system's working out all right for me so far. I spent a lot of time off trail due to weather and illness and injuries and whatnot. But I've been using this same setup every night because I didn't actually bring the wall plug-in adapter for this machine at all because, you know, what do I need it for? So I've just been charging the battery with this when I'm in a hotel or whatever, and then running the machine off of this every night. And so far, so good. This is about a month and a half of testing in. All things being equal, that's about a sixth of the time I'm going to be on trail, although hopefully I'll be doing a lot more miles as the time goes on. One thing I haven't gotten to test yet that I'm a little concerned about, but not too much. Most CPAP machines are only rated for about 8,000 feet of altitude. This one's rated for 8,000. And the trail is going to go way over 8,000 feet. Now, my expectation is it's just not going to flow as much air. It's not going to provide me with as much pressure, and it won't be as efficient above 8,000 feet. It is possible that, like with the low temperature, it's going to have a sensor that throws an alarm. It's possible that, like with the low temperature, it has a sensor that's going to throw an alarm and not allow it to work at all. I've not tested that. I've only been up to about 7,000 feet on the trail so far. And I think the highest I've slept is about 6,000 and change. So I'll cross that bridge when I get to it and provide some sort of update when I do. One of the things that limits your battery choice and why this is so great here is that you need something that accepts a solar charging input, because a solar charger doesn't run at a fixed voltage. A battery's got to have a charge controller. You really can't just put a voltage on it and expect it to go. It's got to be able to ramp up and ramp down and trickle at the top and do all these things that maximize the life of this cell and prevent it from overheating and exploding and all this stuff. And a solar panel is going to provide you a variable voltage depending on how much light it's getting. And so it's important that you have a solar panel that's, especially in this application, it's important that you have a solar panel that works well in partial sun. One of the main things is you want to make sure that you have an MPPT controller rather than a PWM controller, because a PWM controller doesn't work as well, particularly if, say, not all of your panels are getting full sun. So like, for example, when I have mine arranged around my pack, only one or two is likely to be getting a decent amount of sunlight. If you have the right kind of charge controller, you can still get decent power off of that. If you don't have the right kind of charge controller, then you may actually be discharging your battery rather than charging it. And the voltage is continuously variable. Like the open circuit voltage on this one is 33 volts. Maximum power voltage is 22.5, and so on and so forth. So the voltage, you know, can cross a really wide range. And this also has a ton of outputs, which I've gone into the main ones I use. But important thing to note, this also has a 12-volt cigarette lighter outlet, which if you want a high power device to run off of this at 12 volts, this will support 15 amps, which will give you a lot of juice. Now, your variable voltage output, the one I use for my CPAP machine, is limited to a much lower, it depends on the voltage, but it's about 2 amps at the voltages that I'm using, which is just enough to run the machine. So you also have your USB-C in and out. It's got another USB-C that's an out only. There are some peculiarities. I mean, read the manual, but say, for example, if you're running the variable voltage out, you can't use this USB-C output. You have to use this one. And this one's theoretically capable of more power than this one is. You have your USB-A that you can use. This also actually has wireless charging. I tend to shy away from it because that's generally less efficient. Like, it's hard to put a number on it. I think the current numbers are something like wireless charging, you might top out around 70% efficiency versus maybe 85 for a USB-C. And, you know, efficiency is everything. Although, like I said, given the amount of juice I'm using with my CPAP machine, everything having to do with charging phones is kind of a rounding error. But I still don't like to be wasteful if I can avoid it. And it's also got a light on the other end that's kind of cool. If I can remember how to turn it on, I think you do this business. And it's got a bright red light. I think you can also turn it white, or I don't know. I don't really use the light thing, but it's nice to have. And it's annoying if I shine it straight at my camera. So ultimately, this device fulfills a lot of purposes. It wears a lot of hats. It does a whole lot of useful stuff all in one package. Now, in an ideal world, maybe sometime in the future, you could get a really reputable outfit like Samsung or LG or Panasonic, for example, would be, you know, they make really good batteries, by the way, would make a device like this, but it's still very much a niche product. And or even, say, a boutique brand like Goal Zero or something. I imagine if they made this type of a thing, you'd be able to trust a bit more that the specs are what they say they are. And it would have more universal compatibility, like the issue with the USB-C outlet from the solar panel. But these are both cheap, lightweight for the amount of weight and the amount of money. It's the highest performance that I've been able to find so far. For example, you'll see a lot of 60-watt panels that are similar to this, but weigh twice as much. So not everything's perfect, but for what you got, I mean, I've got 3.5, 2.5, a half a pound. I've got everything that I need to operate my CPAP machine with an extra 7-8 pounds worth of gear. And all things considered, that's pretty good. I mean, I used to be carrying more than 10, 12, maybe even 15 pounds worth back when I was using those CCTV cells and everything in my old larger machine. So it's totally doable. And my pack is huge and ridiculously heavy for other reasons too. You know, all my stuff is big because I'm big. So it's all heavier. It's all bulkier. And currently working on shrinking my load down from the 113 liter Osprey pack I still have it. I'm going to ship it out and squeeze it all into this 75 liter ULA one that I just bought. So we'll see how that goes. But for those of you with sleep apnea who don't think it can be done, it's a lot more manageable than you think. It takes a little time. It takes some research. And it costs some money, but it can be done without too much. I mean, the home CPAP machines, especially if you have a detachable humidifier, they're not that heavy. They're just kind of bulky. And so that can be managed, although obviously it's a lot easier to deal with one of the portable ones. And so it's a bit more weight. It's a bit more logistical things you have to think about, because when you're on a through hike, say you're doing the Pacific Crest Trail like I'm doing now, you're having to think about distances and elevation gain and water sources and where you're going to camp, where camping is available, and this and that and the other thing. And in addition to that, you have to think about what your capacity is at, how much you're going to charge, how much you need to charge. So if I have the panel hanging on my pack, I'm getting a certain amount of charge throughout the day. And that's a matter of, say, quantity over quality, because if, say, I'm hiking like 10 hours, but I'm only getting like 10 to 20 watts on average out of it, that's still a pretty good amount. But if I'm stationary, say I stop for lunch, say I'm making breakfast when the sun's up, or say I'm at camp in the evening, if you could get your panel in a good spot where you're getting really good sun, you get a whole lot more juice in an hour stationary than you would in a couple, 3, maybe 4 hours of hiking. But it all adds up. You just have to make sure you're keeping up with what you're using. So this video's been long on technical stuff and short on production value. Is what it is. I'm messing around with this on my downtime while I'm on the trail. But if any of you have questions or you'd like more information, I'll see what I can do. I'm always interested in answering questions and providing more details. So I wish you all the best of luck and happy hunting.